Okay, we'll go ahead and get started with the net. QST, QST, QST. Good evening, everyone. This is Bill, K5LK, Kilo 5 Lima Kilo. Welcome to the Crossroads Ham Radio Club's Tech Net number 4 on the W5 LCR link repeater system. If anyone has emergency or priority traffic at any time during this net, please call break, give your call sign, and the net control operator will recognize you and handle your traffic. This net meets on the first Wednesday night of every month, starting at 8 p.m. local time, and is simulcast on the Crossroads Ham Radio Club's link repeater system covering South Central and Southeast Texas. We utilize a variety of technology options, allowing connectivity to the system. For a complete list of link repeaters with frequencies, offsets, tones, and supported modes, please visit our website at www.CRHRC.org, www.CRHRC.org. Also, you can find TechNet information located at www.technet.CRHRC.org. That's www.technet.CRHRC.org. Tonight's net is being logged in real time over the internet using NetLogger. I'd like to thank Bill, W5ITZ, for filling in for tonight, for being this NetLogger and helping me with check-ins. We've also got several members of the TED committee that are standing by as well and helping out. For tonight's TechNet session, we'll also be on Zoom. If you'd like to follow us along, please join us by going to www.zoom.CRHRC.org. That's www.zoom.CRHRC.org. There are 3 different ways to check into tonight's TechNet. Number 1, check in by NetLogger simply by connecting to the Crossroads Ham Radio Club session, and the NetLogger will see you appear in the Monitor tab. Once the NetLogger sees you listed there, you will automatically be checked in for the net. Number 2, you can also check in by joining us on Zoom using the CRHRC Tech Net Zoom session. Again, that's www.zoom.CRHRC.org. Once in the Zoom session, just type in your call sign in the chat, followed by check-in. Example, W5LCR-check-in. Third, for those that are not connected via NetLogger or Zoom, we will take check-ins on the repeater system after the general Q&A session. During the duration of this TechNet, all Zoom mics will be muted. The Zoom session is being recorded and will be posted on YouTube. All Zoom participants can post questions, conversations, and discussions inside the Zoom chat via text, where other subject matter experts in amateur radio can assist us while the net is simultaneously taking place over the air. Once the TechNet has completed the RF portion, all mics on Zoom will be unmuted. If you would like to follow along, you can download tonight's presentation as well as past presentations on the CRHRC Tech Net webpage by going to www.technet.CRHRC.org. That is www.technet.CRHRC.org. Again, my name is Bill, and my call is K5LK. I'll be the net control operator for the monthly TechNet session tonight, TechNet number 4. Tonight, we're pleased to have John, Kilo 5 Juliet Bravo Tango. He's going to be presenting our main topic regarding grounding and bonding. And after that presentation is concluded, the net controller will ask if anyone has any questions or comments regarding this specific topic. Please provide your call sign, and the net control operator will call on you to present your question. And also, if we have questions in the chat on Zoom, feel free to pose those as well, and we will take them over to John. Once all the questions regarding tonight's presentation have been addressed, then net control operator will open the net for any general tech questions related to amateur radio. At this time, we'll hand the net over to John, K5JPT, for the presentation tonight.
Hi, good evening, everybody. If you could just let me know in chat if you can hear me okay. So, and I'll go ahead and share the presentation. All right, that should be good. Everybody can see that and hear me okay? All right, perfect. Thank you.
Here, okay.
All right. Yeah, so I'm going to dive in with this presentation on grounding and bonding. I will start this by telling you that grounding and bonding is possibly one of the most confusing topics in amateur radio. Everybody needs it. And it's a bit like talking about antennas that you can often, two people can often be talking about the same things and think they're talking about the same things, but are actually talking about entirely different things. And that can get really confusing really fast. So I'm gonna tell you in brief what you need to know about grounding and bonding to keep yourself and your house and your shack safe. So let me just dive in with that. I do recommend this book by Ward Silver, Grounding and Bonding for the Radio Amateur. It's not a very long book, but it's a real treasure trove of information, and quite a lot of this presentation comes out of the information in that book. Okay, so what are we going to actually cover today? A little bit on what is grounding and bonding, why is it important from a safety perspective and an RFI perspective, and a little bit of practical advice on lightning protection and single point grounds and how to build those properly for your shack. Why ground your shack? I mean, there's the basic AC safety ground that every house should have, and we'll cover that. Lightning protection, as mentioned, and of course, preventing RFI and equipment is another aspect of grounding. I'm actually not going to spend a ton of time on preventing RFI and equipment. It kind of comes along for the ride if you do this properly, but that's its own sort of subtopic in here as well. And grounding, this is where people get confused, is grounding as a single term is actually really complicated. Because when we say ground, we mean a whole bunch of different things, right? You've got a lug on your radio that's a chassis ground. If you've got a radio field on your antenna, you call that a ground. That's not a ground connection. It's an RF ground. You've got earth grounds, with these rods, and you have circuit grounds. So you might have a circuit board in a radio or in a computer that's got a common voltage plane in it that's called ground. Those are all different terms that are all called ground. And this is one of the reasons why you get people confused with like trying to do RF grounds with ground rods and all kinds of things like that. It's because we use the same term for many different things, it gets very confusing. Again, I'm really going to focus on the lightning ground and a few aspects of that here in just a minute. And just a little bit more on terminology. Grounding is to make a connection to the earth of some kind. And yeah, as mentioned in the chat, in some countries, they call it an earth connection, same thing. And bonding is actually connecting equipment or connections together to minimize any voltage differences between them. So basically making sure that they're properly connected. If you have corrosion or anything like that in there, you can have all kinds of problems. And so bonding's how to do this properly.
John, can you hear me?
Yeah, I can hear you.
I'm sorry to interrupt. We're gonna have to unkey and key the radio for you. So can we do it and like just say over or because I had to unkey the radio because the repeater's timed out. So if we want to do this, I'll have to key up for you. That way you can do it over the Zoom session.
No problem. What's your timeout?
It's usually about 1:30 is a good safe area.
Okay.
Just say I'll let it unkey and then just continue on. Okay.
Okay, no problem. I'll pause for a second and then I'll dive in. You can key it up.
Okay, here we go. 3, 2, 1.
Okay, we'll try to do this in a punctuated way so we don't time out the repeater. Most of you are familiar with the AC safety ground you have in your house. You got a ground rod out back, hopefully not very far from your circuit breaker panel. This is governed by the National Electrical Code, NEC. All houses should have this by code, but you'd be surprised how many houses don't have this installed. My neighbor, for example, he asked me to check his ground and it wasn't even connected to the ground rod from a circuit breaker panel, which is kind of horrifying. But make sure to check yours, and I'll let the go ahead and do an over, let the repeater drop and come back. Okay, and diving back in, everything else, every other line that comes into your house, whether it be cable, telephone, etc., also should be bonded to your ground rod for safety grounds. Most electricians know the code. They don't know why you should do this. So it's hard to ask an electrician questions about grounding because they don't typically know what a radio operator needs for grounding. Lightning grounding is its own specialization that electricians don't really know much about. That's primarily the realm of in the commercial electrical realm, and they don't yeah, like I said, that's a real specialty. All right, just let it drop before we go to the next slide. Okay, so why should you care about lightning? I know a lot of people may not think that lightning matters to them. For us down here in Southeast Texas, we are in the highest density lightning strike area in the country. We're right up there with Florida with the total lightning density, basically how much lightning we get per square kilometer. So lightning's really important to consider when trying to build your shack properly. Okay, just let it drop, go to the next one. All right, so this is actually an important punchline here, an important point here. National Electrical Code. So for your house to be up to code, it says in section 810.20, each feed line or lead-in conductor from an outdoor antenna must be provided with a listed antenna discharge unit. The antenna discharge unit must be located nearest the point of entrance to the building, but not near combustible material. This antenna discharge unit must be grounded. And just the caveat there, if you have an antenna in your attic or other indoor antennas, those are not subject to this. These are only things that are outside your house that come into your house. And you'll understand that more in just a minute. Just let it drop. Okay, and the reason why this is important is if something happens and you get struck by lightning in your antennas and it comes out that you have not built that to code, it is entirely possible for your insurance company to deny your claim and you don't get any insurance money for burning down your house for not building it up to code, which is a bad situation. Even a worse situation is somebody gets hurt or killed in that process. So, that's one of the big reasons why I'm telling you about this. Go ahead and let it drop and I'll go to the next slide. All right. I'm not going to spend much time on this. We know about the AC safety ground, but I'll get to this more in just a minute because this is where people get really confused, is that if you have an AC ground and a lightning ground, they have to be bonded together outside your house. These are separate systems, but they're bonded together and they can help each other out, but you don't rely on one to deal with the other, right? So you don't rely on lightning protection system to provide an AC safety ground, and you don't let your AC safety ground serve as your lightning protection. Okay. We'll explain a little bit more on how you actually do that on the next slide. Go ahead and let it drop. Okay. This is the one I hear people do over and over and over again, and it is wrong. They say, oh, hey, I have my shack on one side of the house, and what I did was I just drove a ground rod outside my shack, and that's it. And that's my grounding system. That's my lightning protection. So when lightning comes in, it's got a ground rod, antenna discharge unit. I'm good. Right? This is not okay. This is actually a very bad situation. Please do not do this. And the reason why, leave it on a cliffhanger there and let it drop and come back in a minute. The reason why is if you take a lightning strike here and it discharges into one of these ground rods and they're not bonded together, you temporarily raise the grounding potential on one of those rods. And if you have a difference in potential, you have a voltage. So suddenly you've got a voltage difference with a ton of current behind it flowing through the ground wiring in your house. And that means all of that ground wiring has a tendency to melt, set your house on fire, all that sort of stuff that you really don't want to have happen. You want that current to be carried outside your house, not inside your house wiring. Okay. The way you do that, let it drop. We'll pick it up on the next slide, is you have to bond your shack ground, your lightning ground for your shack, to your AC ground. Okay, I see you, Bill. I'll give it a little bit longer to for the drop. You have to bond your shack ground to your AC service entry ground, so the ground rod for your house, with a number 6 solid copper wire outside your house. Just let it drop. And what that does is it provides a dissipation system for lightning. So whichever side the lightning might come in on, whether it comes in from the AC side or it comes in from your antenna side, you've got a system for it to dissipate in, and a low impedance path for that lightning that is outside your house. So those currents do not come into your house. They get dissipated in the ground outside your house. That's why you do this. It's really important. I know it's a pain sometimes. I know a lot of you have shacks on the opposite side of your house from your service entry. You still got to do it, and it's still worthwhile. It's not that much time or money to make it happen. You really can make it happen. Let it drop. I'm not going to spend too much time on exactly how to do this. You don't need a ton of ground rods here. You actually don't even have to have more than the 2. But if you do those, they need to be twice the length of the ground rod apart. So if these are 8-foot ground rods, these need to be at least 16 feet apart. They don't have to be, but it works better if they are. They also need to be correctly bonded together. You don't want to just wrap the wire around it and pretend like it's done. You really need to bond it correctly to that. That's also not hard to do. Okay, let it drop. Okay, I will spend just a few minutes talking about what my own grounding system looks like to give you an example of what this is and some of the costs. This is my grounding panel. Remember, netcode says at the point of entry. I've got antenna discharge units. We'll see those in a minute. A grounding bus bar. And that goes to a bonding bridge, which is a much better way to attach things to ground rods than trying to attach them directly. You've got one conductor that goes to the ground rod, and you can bring as many conductors, several other conductors into this bonding bridge. These are real cheap. They're like $15 at Lowe's. The wire here is all 6 gauge uninsulated copper wire. Let it drop. Just one more point on this. Please do not ever use braid outside in the outside environment. This is inside a box, so it's okay. Outside environment should always be solid wire. Braid is only for inside your shack. Okay, let it drop. Okay, so the inside of the box itself, the D-Mark box I have here, D-Mark box is just off of Amazon. It's just a plastic box you stick on the side of your house, just like all the other D-Mark boxes for cable, etc. I picked up a ground bar that allows you to run your antenna protection discharge units right into it. Here I'm using these polyphaser discharge units. There are cheaper ones. They're probably all fine. It's just easier to ground these, and they look a little fancier. It's a little neater. But you see, I've got one of these diamond ones as well for very specific reasons. It's really not hard to put this together. It's not crazy expensive, and like I say, it can save your house from catching on fire. Let it drop. So this braid then goes into my shack, and inside the shack you want what's called the single point ground. And a single point ground isn't a big deal. It's just it's a sheet of copper nailed to a board. You don't have to spend much money on this. You get a sheet of copper and you nail it to the board. You have a clean side, sort of an outside side, and a dirty side. A clean side inside your shack and a dirty side outside your shack. Every line that comes in to your shack from the outside in that could possibly get hit by lightning needs to be grounded at this point. So if you've got a cable modem or something connected to this, you need to make sure your cable is all grounded here. Network cables, basically, anything that can come in, you need to ground it here. I will show you an example of what this looks like. That's not a clean one here. It's the one I have at home. Go ahead and let it drop. Okay, so this is my own. I've got some braid going up to my radios for chassis grounding. I've got all these, systems, all the antenna lines are all bonded to this copper sheet, literally just the copper sheet screwed onto a board. There's nothing fancy about this. And what this does is any lightning to any of these systems will always follow a low impedance, the lowest impedance path, which is outside to the grounding system, to the lightning protection system. Doesn't matter how it comes into the shack, whether it's over the network cable or anything else, it always follows that path to that low impedance path to ground. So this is a really helpful way to make sure you're grounding every line coming in. Single point grounds are great, and everybody should have one. This one's just mounted underneath my shack desk, so I can always add stuff to it and screw new things in as I choose. Okay, let it drop. Okay, and the real punchline here is this, please take grounding in your shack seriously. It really, really could save your life. I mean, this is right up there with, putting up antennas and hitting power lines as ways that hams get killed. So, make sure your shack is grounded properly. And even if it doesn't save your life, maybe it saves your house. Just a few more details here. Go ahead and let it drop and I'll pick this up. Okay, remember that the lightning follows you want it to follow a low impedance path to ground. You want to get your grounding system as low impedance as possible. It turns out this is quite hard to measure. You need one of these ground impedance meters that clamps on to your ground and gives you a system impedance for it. Below 25 ohms is good. That's pretty much the standard for your house. Mine that I built is below an ohm, which is good enough for a substation or a power station, which is really, really good. It's really easy to achieve that in Houston because we've got really good conductive soil. If you live in Austin and you're sitting on Austin chalk, it's much harder. It's much harder to build a system with this low impedance. So we're lucky here in Houston and most of Southeast Texas, we've got good conductive soil. It's pretty easy to build a low impedance grounding system with not a bunch of grounding rods. You don't need a bunch of extra stuff. Much harder on stony ground, stony dry ground. Let it drop. I would also say that building these systems can be fun. And I can maybe show you the link here. Let's see if this video works. This is a video of the exothermic bonding process. So this is me putting a torch in it. You have this crucible, and what's in here is copper thermite. And once the copper thermite goes, it actually melts copper, and you'll see that copper oozing out of the side of this crucible. And it basically makes a solid copper connection between the ground rod and the wire. This is the best way and most fun way to bond your ground wires to your ground rods, but you can also use clamps and less fun methods like that. Go ahead and let it drop. And I'm just going to leave it there. I really wanted to just hit this lightning ground part of this for you because it is so important here in Southeast Texas, and people do get confused. And please, please, please do not put a ground rod outside of your shack that is not bonded on the outside of your house to your house ground rod. Please don't do that. That's actually a worse situation than having nothing in many ways. Happy to answer any questions. I'm sure there are many of them here, and any comments and any thoughts you have. Thank you.
Wow, John, excellent presentation once again. I got the opportunity to see it a couple of years ago, and it's just great. Thanks for your time. Okay, this is K5LK on the W5LCR repeater system with the Crossroads Ham Radio Club's monthly Tech Net, tonight's Tech Net number 4. We'd like to give a big thanks to John, KJ5JBT, for that great presentation. At this time, we're going to open the net for any tech questions or comments specific to the presentation tonight. We'll take a few call signs at a time and then call on each of you for your questions. Anyone with questions regarding the presentation, please give your call sign followed by your name slowly and phonetically. Please come now.
This is Whiskey 5, Bravo Sierra Alpha, Joe with a question.
This is Whiskey Juliet 1 Delta, WJ1D, Good evening. This is. Okay, a copy W5BSA and WJ1D. Any others right now in the queue for questions on the presentation or comments? This is Kilo Golf 5 India Alpha Zulu. Jim? And Kilo India 5 India Alpha Zulu, Jim? Welcome. Okay, let's turn it over to Joe. Go ahead, Joe, with your comment or question, sir.
Hey, John, thanks for doing this. Really appreciate it. I've always, in your description of how to wire everything, I've always heard about ground loops. And I've got two questions. So if you have a ground loop, what would be an indication that you might have a ground loop? If you want to verify that you don't have a ground loop, what procedures are you most careful about when you're bonding? And then my other question is, what I know sometimes you want to have, I've heard you want to have a chassis ground, and sometimes you may not want to have a chassis ground. So I'm going to throw all that at you and listen to what you have to say. Really appreciate it, John.
Yeah, I mean the ground loop thing is a really confusing thing for people as well. Basically, what a ground loop is a you know a loop of wire, connecting things that is effectively acting as an antenna. You're broadcasting from your antenna not very far away, and basically what you've got is a receive antenna that you set up that's picking up that signal and effectively rebroadcasting it into your ground. You've got an antenna on that and you're picking that up. The way you prevent ground loops, this is a slide I took out. I promise I didn't ask you to ask this question and have this backup slide. This one comes up a lot. What you really want to do is keep your cables bundled together. Because what you want to do is you want to minimize the inductance in the system, and you do that by keeping all your cables bundled together, not loosely distributed around like this. Keep them as short as possible. You want wider wires because those have lower inductance. Fatter wires or braid is good. Bends of any kind add inductance, and I know you can't do this without bending the wires. That's just how it is. Everything here is shown as bent, but just be aware that straighter, shorter, bundled, all of that's good. It minimizes ground loops. If you get ground loops, you can have all kinds of stuff like you can get you get it into your computer. Computer can reset. I've had that myself where it resets. I would reset my computer if I tried to operate on 40 meters before I had sorted out my grounding all kinds of challenges. I'll just let it drop and show you a practical example. So I'll just hit this one real quick. You can see that I don't always practice what I preach. Not all these wires are bundled together. I try to keep them as short as possible, and if they're long, keep them all bundled up. That's the best way to prevent ground loops. And also having good equipment with metal chassis that you can also ground, like USB hubs and that sort of thing. I hope that answers your question.
Thank you. Appreciate it. W5BSA back to net.
Okay, thanks, guys. Let's take it over to James, WJ1D. Go ahead, sir.
Here, I've been in the commercial LMR industry for most of 30 years at this point. And when we're grounding stuff and doing bonding, the minimum size wire we use to bond between ground points, and this gets a little more complicated than what I'm about to say, but the minimum size wire is 2 gauge. And particularly for stuff that I've done for myself after having learned my lessons and burned a few things up, was 2 gauge is pretty well the answer. And good bonding, such as CAD welding, if you can do it, is much more the answer than any of those reversible compression clamps. We're not even really allowed to use those anymore. There's very few instances where we can get away with that. I'm going to drop for a second and reset. And so at least 2 stories over my career of separate grounding systems having not been bonded and public safety dispatchers getting hurt, or large dollar amounts of equipment going up in smoke to the name of millions of dollars. So it is absolutely important. It is absolutely part of the NEC and any of the radio manufacturers' standards to have all your grounding systems bonded in the least impedance possible. And it was kind of a interesting thing to sit here and listen to this tonight. WJ1D, back to Net.
Yeah, I'll just pick that up again. I appreciate the kind words there. It's such an important thing. And yeah, if you go look at a commercial building, they've got those big fat braided wires, not braided, but stranded wires connecting all those lightning rods and all of that stuff. And typically buildings have a full ring ground around them for lightning dissipation. That's the standard for commercial buildings, and it's there for a darn good reason. We usually most of us can't afford to put 2-gauge wire all the way around our house. The main thing is to just keep those currents outside the house with, as you said, a low impedance path. And you just want to do everything you can. I like the CAD welding too. It's a lot of fun. It's what I showed, this exothermic welding of these ground rods. And you learn something in the process of doing it. It's a great way to do it. I don't like the clamps, especially since you're going to bury everything anyway. This is a quick note: your ground rods should actually, according to code, be completely buried, and not what everybody does with the top sticking up above the ground and the clamp on that. The whole thing should actually be buried. But yeah, I'd rather you have something rather than nothing.
Righty, good comments. Let's turn it over to Jim. I believe the suffix was India Alpha Zulu. Is that correct? You're up, sir. K5LK and Tech Net number 4.
Roger, thank you. KG5IAZ. And these are a couple comments. I've got 4 ground rods under my tower. They're all CAD welded with large cable. And the ground cables come up through the concrete so that they're not a trip hazard or a weed eater hazard or something like that. So one of my comments is, anytime you pass one of these ground conductors through concrete, you do not want to have it directly in contact with the concrete, but you want to run it through PVC conduit. And through the PVC, because the iron conduit will act like an inductor and impede the flow of the lightning into the ground. Another practice that I do religiously is on all my HF stuff. When I leave the shack, I disconnect all the coaxes that go outside. I have a panel and if the cable's not connected to the antenna, it's a lot harder for it to go into the antenna, from the antenna into the radio. I almost threw away a ICOM 7610 because of a lightning strike. And let me let it drop. I guess that's the main stuff, and good presentation. Thank you.
Yeah, thank you. If you saw on my single point ground, I'm not quite as devoted as you to disconnect my antennas every time, but I have those antenna switches there that have a ground setting where it's not connecting to any antennas. And when I'm not going to be here, when I'm not in the shack, I always put those on ground, so that at least that single point ground always offers a low impedance path to ground for everything, and hopefully keeps everything outside of my shack, and the radios at least.
Thank you. Great discussions. Looking in the chat, I don't see any questions from the chat. Am I missing any? Can anybody tell me on Zoom? If not, we'll go back to the RF. Don't see any right now. Okay, let's go back to the net here. Any other questions or comments for John's excellent presentation tonight? This is K5LK, Net Control for Tech Net number 4. Please come with your call sign phonetically and your name, please.
W5BSA, I had one more. I hope that's okay. I don't want to hog it.
Let's see if we have anyone else. Anybody else that'd like to throw out a question or comment to John about the presentation now? Don't be shy.
I don't bite much.
Go ahead, Joe.
Hey, John, I've often wondered about, I know including myself, a lot of people will often choose the easiest ground path. So my question is there any concern or danger in using a ground connected it to your home cold water pipe? Is that something you don't want to do or not a problem with?
Yeah, it's a good question. So my opinion, I'm offering this as an opinion, not as an electrician or a wild expert in this, but the more the merrier when it comes to grounding. So like the rebar in concrete, if you can connect a bonding jumper to that, that's called the UFA ground, which is used in a lot of places. This building has a UFA ground also connected to my grounding system. If I had metal pipes, I would have probably connected that too. The more stuff you can bond together, the better. And that's my opinion. There may be reasons why that's wrong. I mean, probably good reasons not to connect to like gas pipes and things like that, but metal water pipes are great. Anything like that, as long as you're offering basically anything you connect to that system should be lowering the impedance of the system. So that should be good. And just offers more space, more ground, more area for the lightning to dissipate.
Thanks, John. Excellent presentation. Okay, one more time. Any questions or comments from the net about John's presentation tonight? Please come now.
Kilo 5 Tango Foxtrot, Bill.
Good evening, Bill. Welcome. Go ahead, sir.
I don't have any specific question or anything, just listening in and wanted to say that I appreciate the efforts here and well, this was a good program. Thanks a lot. K5T squared F.
Thanks, Bill. I concur. Excellent presentation, John. Thanks again on behalf of the CRHRC Tech Net Committee and the whole club. This presentation, we sent it out yesterday, but it'll also be loaded on our website. It's already up there, I believe. We did that tonight. So that's technet.crhrc.org. You can look for the presentation. Also, the recording will be uploaded probably in the next week on the website and then also on our YouTube channel. So again, many thanks, John. This is K5LK Net Control for TechNet number 4, Crossroads Ham Radio Club. We're going to open the next session of the net to just general Q&A. So we'll take a few call signs at a time and then call on each of you for your questions. So anybody with a tech-related question, just give us your call sign followed by your name slowly, and we'll give you the chair. This is K5LK Net Control. Go ahead. All right. Don't be bashful. Now we're going to call on the TechNet guys and gals to get some things going here. It's not going to be an open forum, so feel free to throw out any type of question that you have about operations, antennas, equipment, whatever the case may be. Well, I'm going to take a minute and do a promo for the next 2 months, TechNet. Next month, we're going to do a presentation on field operations in POTA. So we're excited about that with spring coming up here in Southeast Texas. Many of our club members are into that part of the hobby, so we'll look forward to that. And then the following month, we're going to talk about digital operations on HF. So we've got some great main topics coming up the next couple of months. Okay, let's try it again. Anybody have any questions or comments for amateur radio in general? Please come now with your call sign.
W5, be safe for one more for John.
You got the floor, Joe. Go ahead, sir.
Hey, John, I noticed in one of your slides that went by pretty quick, you had it in bold print, no wall warts. So So what do you recommend in place of wall warts? And the reason I'm particularly interested in that, we've got a repeater right now in Katy, and we've got a constant low level. The best we can describe it is 100 hertz hum. It doesn't stop the message, the speaker, from getting through clearly, but it's just there enough to bug us. It doesn't offer that full quieting that we're looking for. And I noticed when you were talking about loose wires and everything, we've got 2 repeaters in a very small shack, and they're not bundled. We've got coax running everywhere. So I know I'm throwing a bunch at you at once, but I see you're not in your head. So can coax that's not bundled and just hanging out in the open, can that be a ground loop type? And anything we can use as a sniffer to try to find out where that hum's coming from?
Yeah, I mean, yeah, absolutely. I would definitely try to bundle the coax together and keep it as short as possible. There's certainly no harm in that. Usually if there's hum, like, we're familiar with like the audio hum that you get, the 60 hertz audio hum. And that usually comes from having 2 bits of equipment plugged into separate ground lines, in your house. And so then you set up a ground loop with a slight different potential voltage between those. And that's where you get that hum. So I would pay attention to where everything is grounded in there and try to make sure everything's bonded together on the grounding side, because that might eliminate it. Because basically you want to equilibrate those voltages with the low impedance connector, with a low impedance connection. Let me just let it drop and I'll pick it up again. Yeah, and on the no wall warts thing, wall warts are just noisy in RF, and if you're plugging them right into the same system where you have your radio, you can pick up all kinds of noise from them. You get RFI from them, not all of them, but quite a lot of them. And so for me on my shack, what I've tried to do is everything that needs power that's immediately in the shack, I try to make it all 12 volts. So that I can use one power supply and power all the equipment, so it all has all the same ground potential from that same power supply, and that eliminates quite a lot of RFI in your shack. A lot of that noise you can get from things like wall warts. It's not easy. It's hard to find monitors that are 12 volts. Often the monitors aren't great that are 12 volts. There's just it's like an endless thing to try to find things that are that run off of 12 volts. Let me just let it drop. And I'll just I'll very quickly share that picture of that slide real quick that you mentioned. And what I was trying to, one of the things to show here is I've got my 12 volt bus of power poles here with all the 12 volts coming off, all the 12 volt lines coming off of it. I try to bundle those together. And then you see the 12 volt is actually powering a USB hub. So most of the other things that I have in the shack, like my hotspot and things like that, all of that is actually connected to the same metal chassis, 12 volt power supplied USB, high quality USB hub, which is feeding the voltage. That's the 5 volt stuff. So you can also you can have better power supplies that aren't wall warts feeding the things that require different power. Metal chassis, they're built well. Always good things to do. Let me just let it drop. And just one more thing I do here, just because I get a little paranoid about lightning, you don't have to do this. This is actually a fiber optic hub for all the network stuff in the shack. So this is actually a fiber optic line, which means there's no metal connection between my network and all the stuff in my shack. There's no Ethernet connection. It's fiber optic. So there's no path for lightning that way as well. Again, you don't have to do that. You can do it wirelessly. That works great. But if you start getting into this mentality, you start paying attention to a lot of things like that and can really start eliminating sources of noise.
Excellent response, Joe. That help you, sir? K5LK.
Yes, thanks very much. I really appreciate it. That makes a lot of sense.
Awesome. Okay, before we got one question in the chat, which we'll bring up here in just a minute, or a comment, but want to give the RFNet one more chance here. Any other comments, questions about tonight's presentation or just ham radio in general? Please bring it up now with your call sign.
KG5
J1D at it again.
Uh-oh, had a double there. I believe it was one of you, James, WJ1D. Was that one?
Sure, that was me.
Okay, we'll continue. Who was the other station?
KG5IAZ.
Gotcha, KG5IAZ. Okay, let's go over to James. Go ahead, sir.
Now, one more thing. The NEC and I believe the NFPA make provisions for something that I want to clarify, because you mentioned something that I think could be taken wrong about bundling cables. Don't bundle cables of different signals. If you have ground cables, okay, hey, great, go ahead and bundle those. If you have signal cables, great, go ahead and bundle those. And power cables, bundle them, but don't bundle them together. If I remember right, the standard pretty well dictates 2 inches apart, and if they must cross each other, they must do so at a 90-degree angle, or a right angle, whatever you want to call it. But they must not run along the same path, and they must not be real close to each other is the basic gist of that. And that may even help the fellow with the repeater and the hum going on there. Don't get all your signal cables all mixed up and right next to each other. WJ1D.
Yeah, I go ahead, Bill. Go ahead. I can pick that up though. Yeah, okay. You're right. Where that really comes into play is running things along AC cables. So AC is the thing that is really important to not run any other kind of cable parallel to AC lines in your in your house or in your shack or anything like that. Because what happens is running it along an AC line, you can get an inductive current on that line by running it parallel to an AC line. That's why you want to have it 2 inches away or more and crossing it at a perpendicular angle when possible. So the classic thing people do all the time, not related to amateur radio, is they run their network cables and their AC lines in the same like conduit and stuff like that. And it's a horrible, horrible idea. Don't run low voltage lines and AC in the same conduit. For the most part in your shack, all the rest of the stuff, the DC lines, I mean, definitely bundle like with like. It's a good idea for sure.
Thank you, John and Jim. And over to Jim now. KG5IAZ. Go ahead, sir.
Roger, this is for John and also James, WJ1D. So I have a Astron linear power supply for my shack. My question is, should I connect the negative of my power supply to my single point ground in the shack?
If it's designed properly, the chassis ground is probably already connected to your negative on your 12 volt, almost certainly. So there is little to no harm in doing that. I would, if it's got a chassis ground lug, you should go ahead and bring that into your single point ground. Otherwise, it's going to get bonded through your radio or anything else, because the chassis ground on your radio is going to be the same ground as what's on your negative on your 12 volt power supply. This gets complicated, but at least in shacks, it's generally the case that everything has the negative voltage ground is the chassis ground, and all that's connected.
Thank you, John, for the comments. Good, excellent presentation. We will stay on here after the RFNet closes on Zoom, and so if we want to continue this discussion on a great topic, we'd love to do that. I do have one question for some folks with the CRHRC on the repeaters. I was having some ice cream with some Katie hams today, and there was a rumor at our ice cream session that there is a new repeater or a test repeater that's got a multi-mode DMR and fusion capability on it. So it's maybe testing. So that fits right into the Tech Net. Anybody from that group could comment on that?
W5ITZ, I can take that one, Bill. Yeah, I happened to see the same rumor in the email newsletter today. Hi. We did deploy a multi-mode DVM repeater in Jackson County. It's actually located, we're going to call it Edna. It has a great reach on it, and that repeater is capable of handling analog FM traffic, DMR traffic. The DMR side is connected to the Brandmeister network. And for the first time for a lot of us, it will also handle Yaesu system fusion. So the control on that repeater is smart. It senses the mode of the incoming signal. If it's analog, it will repeat an analog signal. If it's DMR, it will repeat DMR. And if it's fusion, it will repeat fusion. So it is up and running. It is on 442.925 megahertz. Once again, that's 442.925 megahertz. Analog has a PL tone of 103.5. And if you set it up in your radio, you need to set the PL tone on transmit and receive both. Let me let it drop. Setting that analog tone on the receive will verify that it filters out any of the digital traffic so that you don't hear the DMR squawk or the fusion squawk over your analog radio. For DMR, it uses a color code of 7, a DMR color code of 7. And fusion, a lot of us are just getting our feet wet in fusion, but it is really true if you have a system fusion radio, which would have to be a Yaesu, by the way. It's as simple as programming your call sign into the fusion radio, selecting the frequency either via VFO or by memory channel, and pressing the wires X button, and you will be connected to fusion. So give it a try. Let us know how it's working out for you, and look for some additional information coming in the near future. This is W5ITZ, back to TechNet.
Thanks, Bill. Can you repeat the frequency and PL for you folks that are on RF, please?
You bet. I'm seeing that come across in the chat now. The frequency is 442.925. 442.925. The analog PL tone, 103.5. 103.5 analog PL tone. And the DMR color code is 7. Color code of 7.
Okay, great. That's awesome. Thanks, Bill. And we'll stay on after the RFNet and Zoom. If some folks have some more comments, want to learn more about that new toy we've got here on Crossroads, that'd be awesome. Okay, this is K5LK Net Control for TechNet number 4 on the Crossroads Ham Radio Club. Before closing the net, I want to give everyone an opportunity to get checked in. If you've not already checked in through pre-check-in, Zoom, or NetLogger, now is your opportunity to do so. To get checked in, please give your call sign slowly and phonetically twice. This is K5LK.
Kilo Juliet 5 Bravo Mike uniform. Again, Kilo Juliet 5 Bravo Mike uniform. Fred, Katy, Texas.
This is
Kilo Romeo Tree, India Delta Oscar. Kilo Romeo Tree, India Delta Oscar, Reed and rural Richmond.
I acknowledge KJ5BMU, Fred, good evening, and KR3IDO, Reed, welcome. Any others would be like to be a late check-in tonight? Okay, nothing heard. Again, a reminder, we'll stay on after the net here. We'll be closing it down in just a minute on Zoom, and you can continue the RAG 2. Want to thank everyone that participated in tonight's Tech Net number 4. Also want to give a big thanks to our Tech Net committee members who helped to make tonight's net a success. If you have any questions regarding the Tech Net or would like to join our Tech Net committee and have a lot of fun, you can send an email to technet@crhrc.org. Finally, please note several of us will remain in the Zoom session for the general RAG 2. I'll now close the RF section of the CRHRC's monthly Tech Net. This is K5LK, returning the repeaters back to normal amateur radio use. Good night, all.